Hello guys, welcome you to my YouTube channel. So today we are going to talk about data sets and some theorems. Last time we talked about the section of artificial intelligence and we saw how artificial intelligence can be applied and what is meant by artificial intelligence. Then we are still using the handwritten ticket recognition model to continue this lecture. So I hope all of us collaborate. My name is still the same Damian James. I'm a Mackay University student. So this is the content of my presentation, description, data set. We shall be going through all of them, as you can see. If you want to have a copy of the slides, I'm going to share my Google Drive folder, so you'll be able to see the slides which I'm using. You can download them from my Google Shared folder link in the description. Then I come to the description. What problem am I tackling? If you Some of you when you go to Nira, these guys face the challenges of entering your data into the overfeeding your data into the computer because of different handwriting. Some handwritings are very complex to understand. So this is to delay in the line, and sometimes there's inefficiency in accomplishment of the task of registering all people that come that day. So this model enables us to recognize every character, especially in make characters, very easily within a very short period of time. So we shall be using an AI to time the ticket made by user by scanning the ticket. Now, dataset. Dataset is a collection of data. Just no, it holds information such as medical records, insurance records, to be used by a program when running the system. What they mean? Dataset just a collection of everything your model will be used. The training images, remember I talked about training data in that lecture. The training images, the training data, everything you need to know, everything your model will be used. So that's an example. A full data set has a training set and a testing set, whereby a training set has a training set, as you can see, it has a training set and a validation set. So that's what. Then our model is going to be used some Arabic handwritten character data set. You can create your own data set, but sometimes it's better use data set which was made by someone. You can go to www.cargo.com and you'll be able to find more data sets from there. So I'm going to share a link and among the references, a link to my data set as where you because so you can a link how you can get the data set that I'm going to use. This model or this data set uses some deep learning technique that can effectively recognize Arabic handwritten tickets. Because mine is human, remember, Arabic and humans, they are the same. The difference, Arabic is written using some other, their own language. So then it uses also some convolutional network, as you can see, and some tested math-based database, which has 6,000 training and 1,000 testing images. So you can see there's more data, whereby this makes your system to be more accurate. So some of the factors which I considered before choosing this startup is the accuracy. If you click on the link that I'm going to share in the reference, that link can show you how accurate this database is. It has a 99.1% accuracy. Then reliability, we have variability. It was collected from different institutions, among different people, among different age groups. So there's variability in the data, meaning we can be able to time in every data we want. Then the size of the database, as you can see, it has 6,000 images. That's a lot for a data set that's it for a model to fully at least function well. Then a feature. Features, I'm using some Arabic handwriting ticket images, writing, thicknesses, dot numbers, positions, and shapes. What do I mean by thickness? Thickness, numbers vary in thicknesses, numbers vary in dots. For example, if you look at a 4, dots we talk about the edges. 4, you end up it has like 6, sometimes they are 5, depending on the handwriting. Then you come to position. Position, how do they position themselves? Like if you put a stick on number 4, where will the next stick be? Because if it's down, there you continue. So it's up, there you continuing. Then the shapes also vary. Numbers vary in shapes. So that data set has all the different kinds of shapes which are needed for my data set. Then I talk about the theorem. I have the Bayesian theory. It says the occurrence of event A after B is equal to the occurrence of event B after A by a probability of event A upon event B. What do I mean by that? This is the formula. Probability of A given B is equal to probability of B given A times probability of out of probability of B. What do I mean? That if you want to get the probability of some data occurring given B is true, you get it by getting the probability of B occurring given A is true times probability of A out of probability of B. So I have described all of them. What I've talked about is actually I also wrote it in the slide. The probability of A given is the probability of hypothesis. It's what we want to decide, like it's what we are looking for. Then probability of B given A is the probability of data. So this is the data which is in the data. Then probability of A is the hypothesis that we are looking for. Then probability of B is the probability of the data. It's a training data. Then I come to, so we use Bayes' theorem in many ways. Consider it in the image 01987. So the model has to consider features with each tick and determine the correct output made by the user. If you look at 9, if you look at an 8, the model has to consider the features as we talked about in the opening stage, the shapes, the position, the those numbers, and the consider which class or which output was the user meaning, or what did the user mean. Then therefore the theorem determines the probability our model. So how does it determine? It uses a probability. As I told you, these numbers, for example, if you look at it, we can say that is a 6, or we can say that is a 9. Like maybe someone wrote it upside down. So this model is going to use probability. The class with the highest probability will be able to use, or will be able, it will be taken as the highest class because it has the highest probability of that number occurring in class. So we shall be taking that class because of probability. So we use Bayes' theorem to determine which class an input belongs to. Then I come to naive Bayes' theorem. Naive Bayes' theorem uses Bayes' theorem. You know these theorems, they are the same actually. But if someone teaches you the theorem, you'll be like, they are the same. But really they are different. Now, this uses Bayes' theorem, but with an assumption that data variable is independent on each other. For Bayes' theorem, it says that every feature, for example, the shape of the number, the dot position, they all depend on each other. That's what Bayes' theorem assumes. But naive says no. Shapes and positions, dot numbers, they vary from each other. So that's the difference between those two. So, and naive, it can be used to determine it uses very short period of time to determine a class of an out because for it assumes every data variable is independent of each other. So it's biased, it's called naive because of occurrence of a certain feature is dependent on occurrence of other features. Then it's biased because of a philosopher Thomas Bayes, the guy who made Bayes' theorem. So this forms the basis for Bayes' theorem, and it's suitable to predict a class data with many values, with many features. You know, when I'm going to talk about the differences later. When you come to naive Bayes classifier, it uses some algorithm called the naive Bayes algorithm for binary to the mathematical classification process. So, as you can see, this done by considering the class of highest probability. It's the same as the Bayes theorem, but for it, Bayes, it's very difficult with Bayes when the data features you want to consider, when the number has many features, but it's very suitable to use naive when data variable has many features. So then I talk about the Bayesian network. So this one for it represents data in a graphical manner whereby edges are variables and then whereby nodes are variables and then edges are condition dependencies between the data or between the variables. So as you can see read more about it. I'm going to share a link whereby you can get to know about the Bayesian network. Then but Bayesian network has two types. It has joint probability and then it has also conditional probability. Joint probability of two or more events happen together, then conditional probability that event which occur, event F must have already occurred. Then I come to the differences. As I told you, Bayes' theorem data variables that depend on each other or naive then dependent. Base table for data variables with few features for Bayesian, there but by naive I told you base table for data variables with many features. So the application is different. Because Bayesian theorem, all data variables are dependent on each other. That will make your model too complex to understand the class of the certain thing. But naive is concerned everything is dependent, so every work is a bit different. Then in nature, Bayesian theorem is it's heuristic, but naive is unrealistic because really data data variables depend on each other. So then I come to naive bias versus Bayesian network. Naive bias data variable are independent from each other, that one independent from each other, process data in a different manner, this one process data in a graph manner. So those are the some of the differences between those two. Then I come to differences, how those are the some differences which I outlined for you. So you guys can click on those differences and you get to know about the theorems and then about the data. Then I remain Damian James, student of University. Thank you for watching. I'm going to share a Google Drive folder whereby you can be able to get my slides which I have used. Then I'll show also my email for any inquiries which you want to know about this video. I'll be able to to tell you the answers. So thank you. Don't forget to subscribe and also like